different type of functions. I'll just put a new file. Functions. So far we learned that there's a function. Let's call it high5. And what it does, it prints high5. So we're happy with that. When we run the whole thing, well, as you can see, it does nothing. It does nothing until it is called. Now we called it. So it makes more sense. What we can do next is same from the examples. And number. So this is a typical function with a parameter. So it is not going to print anything different. Let's just call it high number. And another string. Let's just finish it with an exclamation mark. And maybe we can put this backslash as well. And we didn't call it, so nothing happened, obviously. But that's fine. We can fix our errors. We can just call it. It doesn't make sense, but as long as it works. And there we have it, height 10. Well, it doesn't make sense, but it doesn't have to make sense, right? So those are typical functions, simple functions, just printing something and printing whatever parameter was given. So what else can we do? We can define a simple multiply function, which introduces 2 parameters. And what it does, it just returns A times B. It's all gonna be fine, but we need to call it, so it actually does something. So we can, this function got returned, it doesn't print anything. So if we want to see the return, we actually have to print it. So we multiply 3 and 5. I know it's easier to just type 3 times 5 and just put it all in the print, but well, this is as simple function with return as it gets, and I think it should work for what it's meant to be. So this way, actually, this one gives return, and that gives us well, more possibilities when writing programs. There's also other functions, functions with like any given number of parameters one wants to introduce. For example, where do we have it? There we go. A function with multiple arguments. What one does is put a starter, and then when calling the function, we can enter as many parameters as we want. So I guess this code might be the most useful. Let's define this. So this function is sum all nums, meaning the sum of all the numbers. And what it does, we use this magical for loop, which is iterating over all these elements in this list of numbers that the user inputs. So this function got a return, but instead of return, we can just make it print the total, because we want, let's say, make a console application. And when we sum all of these three numbers in the console, we're gonna get a 10. We also, what we could do is write more the sum of, and over here we can type, of course, nums, and is let's try this. The sum of 2 through 5 is 10. So as we can see, this nums is in this case just introduced as a tuple. There's, well, when we introduce concrete numbers to a function, it makes not much difference if it's a tuple or if it's an I mean this list. But because when you call the function, they are not going to change at any point, and we're not going to use them anyway. So it is fine. What one wonders might be that, can I enter an array of numbers 1, 2, 3? Will that work? Well, it does not work. We could make it work, but it would require some changing of the code. So no point. Anyway, you guys should, yes?
I have one question. When the total equals 0, so when we define the total as 0, then we this is basically, this says it's not 0, but it's actually the total of all sums, or like don't really understand.
Okay.
What if I would say total is 1 there?
Because we're starting in the function. The function has got these three numbers introduced, but we need to record the total sum somehow. So yeah, to record the sum, we need to have this container for all the numbers we're going to add there, and that's why
this is basically the starting point. 0
starting point. It's like our container, yeah, container having 0, and to the 0 we can add 2 and 3 and 5 later. But yeah, if we started it with 1, the result would be higher by 1, so we would be having 11. So the sum of 2, 3, 5, well, it's not 11. So that's the thing. If we started with a with another number, but if one just for example defines a none, then it's going to be a problem, because this is no type, and you cannot like mix types that much. Non-type and int just don't work together, this one says. So don't worry if you get this type of messages all over the place. That's also learning, being able to figure out and later on read the errors. Quite often when you have hundreds of lines of code and the compiler might be pointing that you have problem in line 14, most of the time it's accurate, but sometimes the error might be a line above because of let's say unclosed bracket or something. It could be for different reasons. Okay, so this one is none because this is our sum, total sum, and we add all the numbers one by one. We just loop over this list of numbers, and then we just add them, and done. There is another function. I mean, one can generate this type of functions that have one argument for sure, and the others are optional. That's also okay. But there's more types of functions. If you go to Python and in W3 schools, you get more types of functions. For example, this one, the keywords arguments is unknown. Then they use double stars. I didn't see, at least I didn't see this often. So I guess that depends also how you want to write the code. So as you can see, you can define a function this way. I think might be a bit overcomplicated for no reason, because like I mentioned, many things can be done different ways.
It's nice that you can have named parameters also.
Yeah, it is nice.
Because it is possible that you don't recall what are the parameters that were listed in the definition of the function, but you can by using names, it doesn't matter what the order is of the parameters when you're calling the function.
Yeah, it might seem useful now, but later on when we introduce classes or dictionaries and other useful things, then some of the things might be less used than otherwise. But yeah, it's all there for the use. And when one goes to Stack Overflow and finds some solution for different types of things, you might quite often encounter some code like this. You don't have to understand it. What you need to understand is what the function does. I mean, to continue with learning, it's at some point there's some really complicated functions, and one doesn't even care to look at it to see each and every single element, how it's working, because people are over learning already. They don't much care that much anymore. I know what the function takes. I know what the function gives. I'm going to use it because it's really helpful. And that's how it is with many libraries. In Python, you don't learn every single code. You just use the functions that are there. So programming nowadays is a lot easier than it used to be. Well, the other programming languages also had libraries, but it was a bit tougher to read and write code because of the way the code was made. Like Python is this high order language, whereas assembler is I'm not sure if the name is low order, but the assembler is basically working on logical gates of the processor itself. Whereas in Python, it's more like a language that we would speak to one another. More like, it's not exactly that, but it's fairly understandable. Whereas with assembler, you work on some random numbers and gates. I mean, names of different gates, and you get what you try getting it done somehow, but obviously with a lot of less code, you can achieve a lot more in these higher languages. Anyway, I think our time is running out. Have you guys got any questions and suggestions? I'll share these functions. As for these lectures, I'll post them tomorrow. Let's add this. Okay, anyway, as you noticed, troubleshooting channel, go ahead, try different code, paste it, and let everybody have a go at it, and try solving different stuff. And I'm open to suggestions if there's something you guys want to do. I mean, some of this material that got lots of knowledge input is surely boring for you guys. So go ahead and suggest if there's like some kind of project you'd be interested in doing. And if we are able and you have all the tools for that, we can also aim for doing that. I'm hoping that in the future we can check this type of library for visualizing the applications and making somewhat useful applications, maybe not as boring as a calculator, but maybe something more fun. Okay, thank you everybody for attending, and I hope to see you next week. Have a